All right, everybody. Welcome to today's episode of From QA Challenges to Innovation with PRIZ. I'm your host, Debra, Senior Business Consultant here at PRIZ Guru, and we're diving into something that keeps quality professionals up at night: incident resolution and the endless battle against downtime. I'm joined today by someone who's been in the trenches and come out victorious. Alex, welcome to the show.
Thanks for having me, Debra. Always great to chat about quality challenges, especially when we can offer some hope to those caught in the downtime doom loop.
That's a perfect way to describe it, a doom loop. Before we joined today, you mentioned that in your previous role as QA director, your team managed to cut incident resolution time by over 70%. That's impressive. But before we get into how you did it, let's set the stage. Why does traditional incident response so often fall short?
It's a great question, and one I had to answer for our executive team when justifying our transformation initiative. The traditional approach to quality incidents is fundamentally flawed for today's manufacturing reality. In most organizations, departments operate in silos. QA finds an issue, logs it, tosses it over the wall to engineering, who might eventually get to it. Then maybe production implements a fix. Meanwhile, the line is down, or worse, defective products are shipping to customers.
The classic not my problem syndrome. I've seen this firsthand. The quality team identifies an issue, but the information stays locked within their department instead of being shared across the organization.
Exactly. In my previous company, we had a situation where our quality control team discovered a brake component defect, but failed to effectively communicate it to the design engineers. Guess what happened?
Let me guess. The next product iteration had the exact same flaw?
Bingo! And it led to a recall that cost us millions. Information silos are deadly in quality management, but that's just one piece of the puzzle. The second major failing is how painfully slow traditional root cause analysis tends to be.
I've heard it called detective work without the cool hats. Everyone's digging through spreadsheets, machine logs, trying to piece together what happened days or weeks after the fact.
Laughs. I'm stealing that line, but you're right. Without the cool hats and with all the frustration. Traditional root cause analysis is reactive and manual. Teams might spend days or even weeks investigating an issue, often applying quick fixes that treat symptoms rather than addressing the underlying causes. And when you're talking about complex industrial processes, generating mountains of data, sensor readings, maintenance logs, operator inputs, humans simply can't process it all quickly or accurately.
And all this while the line is down, costing thousands per minute in lost productivity.
Right. In automotive manufacturing, downtime can cost between $22,000 to $50,000 per minute. That's why the pressure to just fix it becomes intense, which leads to the third failing: the blame game.
Ah yes, the endless finger-pointing. It's not our department's fault, it's theirs.
It's human nature, unfortunately. In traditional settings, when a defect occurs, the first question is often, who screwed up? Rather than what went wrong in our process. I've sat in too many meetings where engineering blames production. Production blames materials. Materials blame suppliers. And nothing gets solved.
And that blame culture has deeper impacts too, right? People become afraid to report issues.
Absolutely critical point, Debra. When people fear punishment, they hide or downplay problems. I once had an operator who knew a machine was drifting out of calibration, but didn't report it because the last person who flagged a similar issue got reprimanded for causing downtime. By the time the defects became obvious, we'd produced 8 hours of scrap material.
Ouch! So we've got siloed teams, slow manual root cause analysis, and a blame culture. Any other major failings you'd add to the list?
2 more big ones: tiered escalation bottlenecks and fragmented systems. With tiered support, frontline operators or junior QA staff try to troubleshoot before involving senior experts. It's like having a heart attack, but insisting on seeing a general practitioner before a cardiologist. Precious time wasted.
Lies. That's quite the medical analogy. And fragmented systems?
That's when your quality data lives in a dozen different places. some in spreadsheets, some in paper logs, some in someone's head as tribal knowledge. Without a unified view, miscommunications multiply. Production might be using an old specification because they never got the updated one from engineering.
So that's the diagnosis of our patient. Traditional incident response is failing due to siloed teams, slow analysis, blame culture, escalation bottlenecks, and fragmented information. What's the treatment plan? How do we break this firefighting cycle?
That's where the revolution comes in. Forward-thinking companies are completely reimagining incident response with speed and collaboration at the center. The first major breakthrough is implementing real-time monitoring and proactive detection.
You mean catching issues before they become full-blown disasters?
Precisely. Think about Toyota's famous Anden system, a real-time visual alert mechanism that empowers workers to stop the production line immediately when they detect an issue. Instead of waiting for a batch of bad product to be discovered during final inspection, Andon lights and alarms go off the moment an abnormality occurs, and a team leader rushes over to fix it on the spot.
So the idea is to shrink that delay between problem occurrence and problem detection.
Exactly. In our plant, we installed sensors at critical process points that would flag anomalies instantly. When a parameter drifted outside acceptable ranges, alerts went out immediately. Minor issues were corrected within minutes, and larger issues triggered an organized response before they cascaded into bigger problems.
What about analysis? You mentioned how slow traditional root cause approaches can be.
That's where AI-assisted root cause analysis comes in, and this might be the most game-changing development in the whole stack. Modern manufacturing systems generate massive data logs that humans simply can't process quickly enough. But machine learning models can correlate subtle patterns across these data streams to pinpoint what went wrong with remarkable accuracy.
Give me an example of how that works in practice.
Sure. In our facility, we implemented an AI system that ingested data from sensors, machines, and error logs. When we experienced an unusual spike in defects on a particular welding line, the AI tool immediately identified a correlation between the defects and a subtle change in electrical current that occurred after a power fluctuation the previous night. A human team might have taken days to make that connection, but the AI spotted it in seconds.
That's impressive. Companies that implemented these kinds of automated AI root cause tools reduced mean time to resolution significantly, right?
The numbers are staggering. On average, we saw resolution times drop by 78%, from 25 hours down to just 5.5 hours. For critical systems, it's even more dramatic. Issues that might have taken a full day to diagnose now get root-caused in minutes. This lets the team focus on fixing the issue rather than spending all day investigating.
So we've got real-time monitoring to detect issues instantly and AI to diagnose them rapidly. What about the human element? How do we overcome those departmental silos?
That's where cross-functional rapid response teams come in. What some organizations call quality SWAT teams. Instead of a problem bouncing between QA, engineering, and production over days, a dedicated team with members from all relevant functions assembles immediately when a serious incident is reported.
I imagine that requires some organizational restructuring.
It does, but the payoff is enormous. Let me tell you about a methodology we adopted called QRQC, Quick Response, Quality Control. When a defect is detected, operators, engineers, and quality managers gather as a problem-solving cell to diagnose and contain it within the same shift. They use quick root cause tools on the spot, implement a fix, and monitor results.
All within a single shift. That's ambitious.
But achievable. We had a case where we saw a spike in defects related to a particular component. Using QRQC, operators immediately signaled the issue. Managers directly observed the problem, and our cross-functional team performed a quick 5-why analysis that identified a machine calibration fault. The machine was recalibrated and standard checks put in place, yielding an immediate reduction in defect rates.
That kind of rapid collaborative response seems like a complete paradigm shift from the traditional approach.
It is. But what makes it stick is the fourth breakthrough, the the shift to a blameless post-mortem culture. This might actually be the most important piece, because without it, all the technology in the world won't help you.
Let's talk about that. Because cultural change is notoriously difficult. How do you shift from blame to learning?
The key insight is that pointing fingers only drives problems underground, while learning from failure drives progress. In a blameless post-mortem, the focus is on understanding what happened and why, not who caused it. Teams examine all contributing factors openly and honestly.
So instead of writing up the operator who made a mistake, you're looking at the system that allowed the mistake to happen?
Exactly. And this approach has three major benefits. First, people become more willing to report issues and near misses when they know they won't be scapegoated. Second, you get deeper root cause insights because everyone involved can candidly share what they experienced. And third, it encourages a stop and fix mentality throughout the organization.
Can you give us an example of how this played out in your experience?
We had a recurring issue with a particular assembly station where parts would occasionally be installed incorrectly. In the old culture, the typical response would have been to discipline the operators for not following procedures. But when we shifted to a blameless approach, operators freely admitted that the work instructions were confusing and the parts were easily mixed up because they looked similar.
And what came from that honest feedback?
We redesigned the assembly station with mistake-proofing features, color-coded the parts, and simplified the work instructions with clearer visuals. Defects from that station dropped to near zero. But here's the key. Those improvements would never have happened if we just blamed and punished the operators. They would have kept struggling with a poorly designed process while hiding any issues out of fear.
That's a powerful example. It reminds me of something I heard from a healthcare safety expert. Blame is a wasted emotion. It doesn't fix anything.
I love that quote. It's so true. And the aviation industry figured this out decades ago. Their non-punitive reporting systems for near misses have made flying the safest form of transportation. Manufacturing is finally catching up to that mindset.
We've covered a lot of ground so far. Real-time monitoring, AI-assisted analysis, cross-functional teams, and blameless culture. Can you tie all this together with a real-world case study? Maybe from your automotive experience?
I'd be happy to. There's one case that really demonstrates all these principles in action. An automotive parts manufacturer was struggling with a recurring defect on a fuel system component, leading to frequent customer returns and warranty costs. Traditionally, each incident triggered a long 8D report process and weeks of analysis by separate departments, yet the issue kept reappearing.
Classic example of the traditional approach failing.
Right? So the company overhauled its approach by implementing a daily fast response meeting system aligned with General Motors' QSB methodology. Each day, the quality team flagged any significant defect from the last 24 hours and immediately assembled a small cross-functional team: quality engineers, production supervisor, maintenance tech, design engineer, to handle containment and root cause analysis.
So instead of waiting days or weeks for all those specialists to get involved sequentially, they were all in the room together from day one.
Exactly. In one instance, they found weld splatter on the component was causing leaks. Within hours of detection, the team traced the root cause to a misaligned welding jig using a quick 5Y analysis right on the shop floor. They halted that line, fixed the jig alignment, and added an automated sensor to catch misalignments going forward.
And I'm guessing they didn't stop there. They probably looked at how to prevent similar issues in the future.
You got it. The issue owner reported the fix in the next morning's meeting, and the items stayed on their fast response tracking board until all follow-up actions were completed, updating work instructions, training operators on the new sensor system, and so on. Over the next quarter, defect rates on that line dropped by over 60%, virtually eliminating customer complaints for that issue.
That's impressive. Any other benefits they saw?
Here's where the learning culture really shines. By rapidly addressing the problem and sharing the knowledge, they prevented similar issues on a related production line that was about to introduce a similar welding process. That's the power of turning incidents into organizational learning rather than just fixing and forgetting.
It sounds like there's a compounding benefit to this approach. Each incident becomes an opportunity to prevent future problems, not just in the same area, but across the organization.
Absolutely, and as your incident response improves, you start spending less time firefighting and more time on proactive improvements. It's a virtuous cycle that builds on itself.
Let's switch gears a bit. We've talked about how these new approaches can revolutionize incident response, but I'm sure there are challenges to implementing them. What obstacles do companies typically face?
The biggest one is resistance to cultural change. Moving from a blame culture to a learning culture requires leadership commitment and persistence. Technical solutions like AI tools can be purchased, but changing hearts and minds takes time.
Any advice for quality leaders trying to make this shift?
Start small and build on successes. Find one production line or product family with recurring issues and apply these principles there first. When people see the dramatic improvements in resolution time and the reduction in repeat incidents, they become believers. Also, leadership has to walk the talk. If executives still ask who screwed up when an incident occurs, nothing will change further down.
How about technology investments? Not every company can afford cutting-edge AI systems.
That's true. But there are scalable approaches. Even simple real-time dashboards showing key process parameters can dramatically improve visibility. And cross-functional teams don't cost anything to implement. It's just about bringing the right people together. Start with the organizational and cultural elements. Then add technology, as you can justify the investment with early wins.
One last question before we wrap up. If a company implements all these changes successfully, what kind of improvements can they reasonably expect?
Based on my experience and industry benchmarks, here's what's achievable. Mean time to resolution can drop by 60 to 80%. Repeat incidents can be reduced by 40 to 70%. Overall downtime from quality incidents can be cut by 30 to 50%. And perhaps most importantly, the organization develops a much higher capacity for learning and improvement that pays dividends far beyond quality incidents.
Those numbers would certainly get the attention of any executive team. Any final thoughts for our listeners?
Just this. Rethinking incident resolution isn't just about fixing problems faster, though that's important. It's about building a more resilient organization that learns from every stumble and continuously improves. The companies that master this approach don't just save money on downtime. They gain a significant competitive advantage in quality, delivery, and innovation.
That's a powerful closing thought, Alex. The incident resolution revolution isn't just about slashing downtime. It's about transforming how organizations learn and improve. Thank you so much for sharing your expertise and experiences with us today.
It's been my pleasure, Debra. Here's hoping more companies break free from the firefighting cycle and embrace these new approaches. The results really do speak for themselves.